Your brain is a pattern-seeking organ, yet it thrives not on spontaneity but on routine. A common belief is that disruption of habits can lead to creativity, but the mechanism says otherwise. Within 48 hours of habit disruption, the prefrontal cortex shows increased activity to compensate for unfamiliar tasks. This adaptation is energy-consuming, requiring up to 25% more glucose than during routine tasks, according to a 2020 study by researchers at Duke University. Rather than fostering creativity, disruption taxes your brain's resources, leading to cognitive fatigue. Routine provides a neurological baseline, reducing cognitive load and conserving energy for complex decisions. Inside your basal ganglia, routines are encoded as neural loops through a mechanism called synaptic plasticity. Contrary to the idea that habits are static, this region is constantly rewiring, adjusting to new patterns over time. A 2019 study from MIT showed that habit loops can be altered in as little as 21 days, depending on reward consistency. Neurons form stronger connections through repetitive engagement, creating a behavioral autopilot. When disrupted, the basal ganglia must re-establish these loops, demanding more dopamine to motivate new routines. This biochemical adjustment underscores how deeply entrenched routines become. In the hippocampus, cortisol levels surge during routine disruption, affecting memory retrieval and emotional regulation. A study conducted by Stanford University in 2018 revealed that cortisol can decrease dendrite density by up to 15% within a week of chronic stress. This reduction impairs synaptic connections, making it harder for your brain to access stored information. The hippocampus, crucial for forming new memories, struggles with disruptions, causing emotional and cognitive dissonance. The routine provides a stable platform for memory consolidation, reducing the need for stress-induced cortisol spikes. Your amygdala becomes hyperactive when routines are disrupted, amplifying anxiety and fear responses. Contrary to the belief that spontaneity is freeing, unpredictability can lead to increased alertness and stress. A 2017 neuroimaging study published in Nature showed that unpredictable environments increase amygdala activity by 30% compared to predictable settings. This heightened state primes your brain for perceived threats, often resulting in a feedback loop of stress and anxiety. Routine acts as a buffer, regulating the amygdala's activity and maintaining emotional stability. Dopamine signaling, essential for motivation and pleasure, is heavily influenced by habitual structures. Disrupted routines can lead to a downregulation of dopamine receptors, making it harder for your brain to experience reward and satisfaction. Research from the University of California, published in 2021, showed a 25% decrease in dopamine receptor availability following abrupt lifestyle changes. This decrease translates into diminished motivation and satisfaction, reinforcing the need for routine. Habits provide a consistent framework for dopamine release, stabilizing mood and motivation through predictable reward pathways. Cortisol, the stress hormone, exerts a profound impact on the hippocampus by reducing dendrite density. At a cellular level, cortisol binds to glucocorticoid receptors, triggering a cascade that dismantles synaptic connections. A study by Rockefeller University in 2019 found that high cortisol levels can lead to a 20% reduction in dendritic spines over several days. This structural change impairs your brain's ability to form new memories and manage emotions. During routine activities, cortisol levels remain stable, preserving these vital neuronal connections. When routines are disrupted, the cortisol-induced erosion of dendrites compromises hippocampal function. The amygdala and prefrontal cortex work in concert to regulate emotions, yet when routines falter, their connectivity weakens. Stress-induced hyperactivity in the amygdala can suppress the prefrontal cortex, impairing decision-making. A 2020 study from Yale University demonstrated a 15% decrease in functional connectivity between these regions under chronic stress. This disruption makes it difficult for your brain to evaluate risks and rewards rationally. Routine buffers this connectivity, enabling the prefrontal cortex to assert control over impulsive reactions. Without this neurological tether, emotional regulation becomes erratic, skewing perception and response. Dopamine receptor downregulation occurs when excessive novelty disrupts routine, altering your brain's reward processing. In the ventral tegmental area, dopamine neurons must constantly adjust to changing stimuli, which can lead to receptor desensitization. A 2018 study from the University of Toronto measured a 30% decrease in dopamine receptor sensitivity after prolonged exposure to unpredictable environments. This downregulation reduces your brain's responsiveness to pleasure, impairing motivation and focus. Routine stabilizes dopamine signaling, maintaining receptor sensitivity and optimizing reward pathways. When disrupted, the loss of this homeostasis can dull the experience of joy and satisfaction. The basal ganglia encode habits through a process of neuroplasticity, where synaptic connections are strengthened with repetition. Disruption forces this system to adapt, demanding increased neural energy. A 2021 study from Harvard Medical School showed that habit reformation can increase neural firing rates by 40%. This increase requires more ATP, the energy currency of the brain, to sustain new synaptic growth. Routine allows the basal ganglia to conserve energy, operating efficiently on established neural loops. When routines crumble, this energy-intensive process strains cognitive resources, complicating the formation of new habits. Stress impacts neuroplasticity by altering BDNF, brain-derived neurotrophic factor, expression, crucial for synaptic growth. Under routine conditions, BDNF supports neural adaptability and cognitive resilience. Disruption triggers a decline in BDNF levels, as shown in a 2017 study in biological psychiatry, which reported a 32% decrease under chronic stress. This reduction impairs the brain's ability to forge new synaptic connections, stifling learning and memory formation. Routine elevates BDNF expression, promoting a fertile landscape for neural development. When routines break down, the subsequent BDNF drop limits your brain's plastic potential. Chronic stress differs significantly from acute stress in its impact on brain structure. Acute stress can sharpen cognitive function temporarily, enhancing focus and alertness. However, chronic stress leads to persistent cortisol elevation, degrading hippocampal and prefrontal cortex function over time. A longitudinal study from King's College London in 2019 observed a 14% shrinkage in hippocampal volume among individuals exposed to prolonged stress. This structural loss diminishes memory capacity and emotional resilience. Routine acts as a barrier against chronic stress, maintaining neural integrity and function. Without it, the damaging effects of chronic stress become more pronounced and lasting. Popular psychology often touts novelty as a route to happiness, yet neuroscience reveals a more nuanced reality. Brain imaging studies show that the default mode network, DMN, associated with self-referential thought, becomes less active during novel experiences. A 2021 study in Neuron demonstrated that DMN activity decreased by 35% when subjects engaged in unfamiliar tasks. While this might suggest openness, it can also lead to disorientation and stress. Routine stabilizes DMN activity, providing a structured cognitive environment. Without this anchor, your brain struggles to integrate new experiences into existing mental frameworks, leading to cognitive overload. The self-help industry often claims that breaking routines can lead to self-discovery, yet peer-reviewed neuroscience shows a different picture. Synaptic pruning, a process that occurs heavily during adolescence, is crucial for cognitive efficiency but can be triggered by stress in adults. A 2020 study from the Salk Institute found that stress-induced pruning can eliminate up to 30% of synapses in the prefrontal cortex. This loss impairs decision-making and emotional regulation. Routine mitigates unnecessary pruning by reducing stress. When routines are disrupted, the brain may erroneously prune essential synapses, leading to cognitive decline rather than growth. Vagus nerve signaling plays a crucial role in maintaining homeostasis and stress response. Routine impacts this nerve's function by enhancing its signaling capacity. A 2018 study from the University of Pittsburgh showed that routine physical activity increased vagal tone by 25%, promoting calm and stress resilience. When routines are disrupted, vagus nerve signaling weakens, leading to heightened stress responses and impaired physiological balance. Routine activities, such as regular exercise and meditation, enhance vagal efficiency, stabilizing heart rate and emotional responses. Without this support, your brain and body become more susceptible to stress-induced disruptions. An intriguing study published in Psychological Science in 2022 found that individuals who maintain consistent routines report a 20% higher sense of life satisfaction. This research, conducted with a sample of 1,500 participants, sheds light on the long-term benefits of routine. It suggests that the stability provided by routine supports neurological consistency, enhancing overall well-being. This doesn't imply avoiding change altogether, but highlights the brain's preference for predictability. Routine empowers your brain to allocate resources efficiently, enabling you to thrive amidst life's inevitable uncertainties. The numbers underscore a crucial aspect of cognitive health often overlooked.